plotting the growth like that. So this is x direction. This is the amplitude of my u prime, for example. Okay. And usually there is a particular re theta corresponding a particular x location that starts to support any growth. So let's say this is the environmental, this is the seed level of the unsteady disturbance. This seed level is going to go up or down depending on the how clean the initial flow is. Okay, and so this is the first location can grow, and the growth is going to be very momentary. So it is going to grow over this region. Starting from this region, it'll decay, right? So let's say this is the log space, so that any growth is going to be a linear curve. Okay, so but this is one particular frequency. So this is the highest frequency. And later on, another curve starts over here, but enjoys a larger range of growth. Okay, that corresponds to this kind of curves, different lines through this instability region. Okay, later I can have a curve that goes like this for different frequency, and yet a different frequency like that. So for each frequency, starting from here to here is the region of growth. Actually, if I draw this better, all these lines should start with a zero rate of growth, so they all should be tangent like that. They all should be like that. Okay, for each subsequent lower frequency, usually you see a wider range of growth. So if you think of superimposing all of these different frequencies and draw what is the maximum amplitude of all these frequencies, you can draw an envelope that envelopes all of these growing and then decaying curves. Each point on the envelope corresponds to a different frequency.
It's only the maximum that's shown.
It's only the maximum that is shown. Yeah, that's right. Okay, and it has been figured out that for some for the Faulkner-Scain family of solutions, at least, the envelope looks like that, and particularly they all look like straight lines. Okay, so they all look like so the rate. So okay, so if you look at the rate of so this n is basically n is the log of the disturbance divided by the seed disturbance. So basically in log scale, what is the distance between here and here? So you can write this as the n factor. Okay, so basically you can think of it as a magnitude of the small unsteady disturbance, where in the log scale, taking the initial seed level to be 0. Okay, so that is the physical meaning of this n variable.
Could you explain n?
So
what is the seed?
So seed is the magnitude of the initial disturbance, which we assume is a white noise, which is the same for all different frequencies. So it's the energy of the white noise, right? So in the white noise disturbance, how much energy is in every frequency? All right. Okay. All right, so this n is this n is a linear function of re theta for every different h. So that promotes us to make a transition model that is based on trying to predict the growth of n, right? Because the n being a linear function of re theta means that I can predict dn dx as a function of, so is a function of, so dn dx I can represent it as a function of re theta and h, right? And particular, it is in the form of dn dx. No, it's particularly in the form of dn dre theta, right? Because in this plot, the straight line is n as a function of re theta times. So this is a function of h, because for different h the slope is different, times dre theta dx. So that is how fast the theta would grow as x advances. All right. So we know that. So now what does this depend on? We know that dre theta drex. If we normalize everything, so let's see. So dre theta dx is a function of h, and it is also, it's an inverse proportional to theta. Dre theta dx, it's so dre theta drex would be, so dre theta dx,
d theta over dx.
right, that's d theta over dx, and d theta over dx is d theta over dx would be, okay, so let me try to draw the plot. So if this is x, this is theta, the growth is a square root law, right? And we expect theta square over nu to be proportional to x. So for a fixed h, theta square over nu is a linear function of x. So if you take derivative on both sides, so that is theta times d theta is going to be proportional to dx. So d theta over dx is going to be proportional to 1 over theta, right? Actually 1 over re theta. So so this is equal to 1 over re theta times a function of h.